Hello everyone, good evening to all and happy independence to each and everyone. So welcome to the ninth day of certification program on machine learning and GenAI. So I hope up to now you have learned all the basic concepts of machine learning and deep learning. Yesterday we have seen all the CNN concepts. So I hope you'll have some idea on what is a machine learning, what is an AI, what is some difference between ML and DL and AI. So some basic concepts and how to use a basic algorithms in hands on that. I hope you will have some idea. So I'm just seeing that feedback also. And most of the people are commenting from medical field that the content is very new to them, but they are able to understand almost all the concepts whatever I'm teaching. So I'm very happy that you are able to understand my teaching. And of course, yesterday a few people are commenting like they're not able to get an audio. So actually, day before yesterday we got so much problem for the audio. So we have changed our mic and we have changed our here the video content, the video quality, everything. We are very careful from yesterday, from the before day before yesterday experience. So still your persisting problem means that may be something, network issue maybe. Definitely not from our side. So next thing, few people are asking like provide the PPTs today. By the end of this session, I'll provide this complete PPT to you, and recordings also we will share by this end of today, because by this today we will end all our teaching sessions. Tomorrow will be our complete exam. So before going to the concept, I just want to clear that exam thing. So exam maximum questions we will give you from the quiz, whatever quiz you have attended, like that only. All the questions will be like MCQs only, multiple choice only. But I'm thinking a few questions like some, if I'm giving 20 questions, in that some 5 questions should be like a simple programming syntax I'll give, or I'll ask what syntax you are going to use a for particular module, whether you want to load a data, what you are going to use and how to do load a data. That maybe 5 questions will limit to that programming syntax. The other remaining thing will be like a complete theoretical part, all multiple choice questions. So that is the pattern for exam. So almost if it is a 20 questions, then 15 questions will be all the multiple choice questions, and 5 questions will be that number. Still we are discussing. So tomorrow you'll get maximum, that will be some 20 questions or 40 questions. That number we will decide, and we will let you know through our WhatsApp channel. And whatever maybe that is 20 or 40, but most of the questions are theory parts, theory multiple choice questions, and only 5 questions will be related to some coding. So there also we will give the multiple choice only. So just you have to select the correct one. We will ask you some module, what will be the syntax, and what you do when you fit a line, or some encoding, some data processing techniques, that we will ask. Everything whatever we have covered in this session, that almost you'll get in that exam paper also. So this is what about exam pattern. And tomorrow will be completely question and answer sessions. So like last Friday, it will be 1 hour session, and in that tomorrow after that question and answer sessions, we'll give you the online link for exam. So you can fill it that exam, and we will give you time to complete that. And depending on that exam result only, we will give you the certificate. And of course, all are aware of that attendance should be 80%, and you have to get the marks of 75% in that exam. So that is the conditions we are taking to give you a certificate. And if you have any doubts and any questions about exam pattern or exam and how to write that now certification exam, still any other questions are there, please comment in the comment box and we will clarify today. And tomorrow will be a 1 hour session and then it's completely question and answer. So by today, the whatever I'm going to teach, that teaching sessions will be completed by today. So yesterday we have seen all that CNN convolutional neural networks thing, and we have seen all the activation functions, regularization functions, and one CNN medical image processing also we have seen yesterday. We have considered the X-rays, chest X-rays image, and uh, we learned that how to deploy that a new X-ray and how can a machine, whatever model you have built through convolution neural networks, how can it able to build that that X-ray. That also we have seen in the practical session. And one more thing we have seen in our CNN is MNIST, means handwritten images. If we have a handwritten numbers, we have, and how to recognize that, how to train that model. And if you give a new handwritten number as an image, then how your model is, how much efficiently your model is, how much accurately your model is predicting that number. That also we have seen yesterday. And also yesterday we have learned all the, in CNN particularly the difference between normal artificial neural networks and the convolutional neural networks. And of course we have learned the pooling, what is a pooling, and what is the feature map, and what is the feature engineering, what is the convolution operation. So everything whatever related to CNN we have learned yesterday. What do you mean by a stride, what do you mean by a padding. So I hope you have some idea on CNN, because when you are in a medical field or when you are doing something related to images, when it comes to images, when it comes to image processing, CNN are the most important part to deal with the images. There mostly ANN won't work, any neural network won't work. Or if you are going for further depth into deep learning, if you want to do some fusion effects, or if you want to do some generative AI, if you want to do something, you are going for depth into that deep learning, you have to know the complete understanding of CNN. So that's why I'm stressing again and again. So better be strong in CNN, in complete neural networks. And next we started RNN, but because of the time limit, we have stopped in between. So we will continue that RNN today, and then we'll move on to GenAI. So RNN actually the problem of whatever neural networks up to now we have, either it is CNN or artificial neural network. The main problem with these two are they don't know what happens in the previous layer. If you consider a CNN neural network, the hidden layer, the information will be passed from input layer to hidden layer. So all the information after doing all the feature engineering, completing when the image will be reduced to a minimum size, and that will be flattened, and then that information will be passed to input layer. Then weights and biases will be added, and that information will be passed to hidden layer. But when the information comes to hidden layer, the hidden layer neurons will not able to remember anything from the input layer. They don't know the history of the input layer. But in few cases that will be a problem. So whenever we want a sequence, suppose I want to write a translation project. So I am giving the text in my English language and I want to translate that complete thing in my another native language like Telugu. So in that particular cases, what happens if I give how are you as a English language as an input, I transferred how as a node and R as a node and you as a node, and I transferred that thing. If the machine learning model if don't know that sequence, it should be how are you, that sequence should be followed. It cannot take you as the first node, R as the second node, and how as the third node. It cannot able to take. If it is taking that thing, you cannot translate the output in a correct way. So that is the where we are getting the sequence problems. Or one thing is translation, and one more thing is in when you speak something, when you command something. So just like Alexa, if you are commanding, if you are asking Alexa to do something, means Alexa able to know whatever you are telling. So if you tell Alexa, bring me a book, bring me a glass of water, so that complete thing Alexa able to understand. Alexa able to understand the complete sequence. So if Alexa is understanding like um, something water, bring some, if the order is changing, then the action will be inaccurate. So in some cases, particular cases, particularly in text cases or in time series, wherever you need a sequence, then we have to go for another neural network where each and every layer will have the history of the previous layer. Each and every layer will know what happens in my previous layer. That is called a recurrent neural network. That is called RNN. So RNN, if the first layer is provided with all the inputs and weights and biases, when it comes to next layer, so the same output, with that same output whatever coming from the first layer, it will be provided with that output, and also whatever input we are giving, that also it will be provided. So both will be provided to the second layer. So second layer will have all the history of the first layer. That is what happens in RNN. We'll see that. What yesterday we have seen RNN. RNN neural networks means recurrent neural networks are a class of artificial neural networks designed for sequential data such as time series, text, speech, and video. Unlike traditional feed-forward neural networks, RNNs have connections that form directed cycles which allow them to maintain a memory of previous inputs, making them ideal for tasks where context or sequential order is important. So wherever, suppose when you see your Gmail, you might have seen now, if you are typing something, automatically if it will refer the next word. So if you are typing, I'm waiting for the for your next, then it will refer the words next mail or next response, something it will refer. So that is a case of actually Gen AI. But to do that, the sequence, to maintain that correct sequence, that works on RNN. The basic is RNN there. So RNN neural networks are the base for that structure of that sentences, email sentences. And this RNN neural networks also have the same structure of CNN, like they'll consist of an input layer, hidden layer, and output layer. And this is the structure of uh, this layer. I mean, RNN layer, RNN neural networks. So actually, this is the structure of RNN. So when you expand this structure, this is the first one. Suppose let's say I am taking a word of, I want to produce a word of how are you. So this sentence I want to give as a input, and I want to translate, and I want to get an output of, in Telugu I want to get this as my output. So what I'll do first, this using a vectorizer or a word embedding, I'll convert that into some matrix or heart encoding I'll use. So heart encoding is nothing but vectorization dictionary. Using the dictionary indexing, I'll convert this as a vector matrix. Let's say this is something like some vector or some matrix I got. Using some encoding methods, I have converted everything into a numbers. Now I'll process this word to first layer, first node. So let's say first node I have transferred how, and for this how I have added some weight. So this is the input I have made at particular time. At suppose the starting time at the first cycle, this is nothing but the time. At first cycle, I have transferred how to this neural network, the hidden layer, and I got an output of something. Let's say some y. Now this y1, let's say this is the y1. Now again that y1 should be supplied to the next layer. Now here the concept is we don't have so many layers like in our CNN or ANN. Only one thing will be there. So only one thing will be there. So like this, one layer will be there. So first instant time one, I'll supply how, and I got an output of something how. Let's say some in Telugu, I got some output. And then again at another time, next instant, at a time 2, I am supplying R. So with this R, at the same time, I am supply this whatever output I am getting here, the same thing I'll supply as input. So how also I supply as input. And now I'll get an output of some y2. And again with this output, so here I am supplying the third word as Q. This is my X3. This is my X2. This is my X1. So with X1, with X2, with X3, whatever thing I am getting from the previous one, that also I'll supply here. So like this, every word will be repeatedly supplied there. So there won't be any different nodes. Only one layer will be there. To that, the different timings will be there. So this is the first instant, this is the second instant, this is the third instant. With the timings, we will supply that information, input information. So whenever you have supplied this information, with that output, the same this output xt at that next time, the same thing again will be transferred to the second node and an output will get at particular time. So this is what happens in RNN, recurrent neural network. So this thing is, it will remember all the history of the previous node, previous layer, what happens in the previous layer, or what happens in just a moment before. What happened? It will have all the history of the previous nodes. This is what RNN. So how a RNN will differ from ANN? So ANN do not have looping nodes that are called what that are looping nodes are called feed forward neural networks. So there won't be any looping nodes. There won't be any repeated back nodes. There won't be any history. That is called a feed forward. Feed forward, I have already explained you. It just move on to a front from input to hidden. So while transforming, it will just added weights and bias and activation function, and it will be transferred to second layer, and then the remaining things will be added to output layer. So again the same weights and bias and activation function will be added to the output layer. So but in information moves from input layer to output layer if any hidden layers are present unidirectionally in a feed forward neural network. These networks are appropriate for image classification, for example, where input and output are independent. But if it is a sequential, this is not suitable. So this is the recurrent neural network and this is the feed forward neural network. Only the difference is here we don't have any looping. Here we don't have any looping. So the looping is not there. Looping is nothing but the passing the information of the previous layer. Now, but what is the problem? What is the problem with RNN? What's the main problem with RNN? If you are having just 3 words of how are you, then it is a simple RNN network. But instead of that, if I want to transfer a complete 10,000 pages book or some 30 million of words as a project. So every time, after completing a page, that page maybe the last line should be needed for us for a sequence of next line, not the first line. We don't need, but RNN will remember each and everything what happens in the previous layer. So when it comes to, suppose you will have in the loopings 30 million words you have, means 30 million loopings you will have. So at the 30th million loop, how many words you will have, how many inputs you are going to transfer to that neuron, just assume. So it's a very, sometimes it's just like overfitting. So almost the memory will be, storage will be occupied a much, and this the time will be consumed, and the errors will be more in that particular cases. So then LSTM comes into picture. So LSTM is nothing but long short term memory. So the name itself indicates long short term memory. So this long short term memory is nothing but it is a RNN network, but in just in general words, what LSTM will do, wherever you don't want that history, wherever you want that history, so that will be divided, easily predicted by LSTM. So wherever you want to have a long memory, wherever you have a short memory. So maybe in some cases, the starting, when you are doing a time series data, maybe for a sales prediction or some stock prediction, maybe day sales will be important for us. Maybe before day will be important. Maybe 1 week may be important. 1 month may be important. But before 5 years of data, we don't need. We don't require to analyze our prediction. So that data will be eliminated, ignored by LSTM. That will not be considered by LSTM. So doing that, the overfitting problem will be reduced. So automatically the accuracy will be increased. That's what LSTM will do. So LSTM will decide that where you should have a long memory, where you should have a short memory. So long, short term memory. Sometimes we need very less memory, history of the very less memory we need. In that particular cases, it will ignore the remaining memory. It will store uh, whatever history you want. That only it will be stored in this memory card. So we'll see that yesterday's lab session we have completed in half only. This is a movie IMDb. You already, I think you are aware of IMDb reviews. Whatever new movie comes, it will give you the reviews. The website will give you the reviews, and mostly it will have all the positive reviews and negative reviews. So, so that data I have considered here for RNN. Mostly RNN will be used for text translation. NLP, wherever you are dealing with the NLP, mainly text, natural language processing, when you are doing text classification, when you are doing sequential data. So then in that cases, we use RNN. So I have considered here the data set. I imported the data set of movie reviews. I want to classify whether a particular line is a positive review or negative review. So for that, I have trained my neural network with a lot of comments and the outputs labels as positive and negative. And that data set I have considered from IMDb data set. So here, this is the IMDb data set. Wait, I'll zoom it little bit. Zoom it. So first for that, I am importing the Keras data set. So first here I'm importing the IMDb dataset from Keras dataset as I'm doing the neural network. So I basically I'll be comfortable with the Keras and TensorFlow. So I have downloaded the dataset from Keras, and now completely it is a sequential one. I want to do the sequence. So I have in the pre-processing I'm importing the sequence module, and here this thing is for the lines. So suppose in my whatever data set I am considering, maybe the line first line will be somewhat like the movie is very good. So it will have some seven words. The length of the sentence is somewhat 20 letters. But in the next sentence, I have only 10 letters. So the no when you convert that into vectors, the matrix size will be differentiated and the machine will not able to understand that. So what I am doing at the starting, I am fixing the length of that and I am fixing the features. So 10,000 only I am taking. So 10,000 repeated words I am taking. So that I am taking as maximum features. So whenever that repeated word occurs, depending on that repeated word, the label will be decided. That machine will be trained with that repeated words. So maybe the movie is very good. So very good is a repeated word in most of the positive comments, and so that I'll take. So like that I am limiting that features, maximum features as 10,000, and maximum length of that sentence I am taking maximum length of that words, the letters in that sentence I am limiting to 500. So yeah, whatever maybe, if it is a bigger line, I have to prone that, I have to cut that. If it is a short line, I have to make it fix with zeros in my vector, in my matrix. So that I am fixing that maximum length should be 500, and batch size I am considering as 32. So every time for the training I am sending 32 at a time, 32 sentences, 32 examples I am sending at a time. So here I am just downloading the data and I'm telling the machine that these are the input training inputs and testing inputs and training outputs and testing outputs. And this is the maximum features already I have given, and number of words should be equal to this 10,000. Numbers, whatever matrix I am taking, that should be maximum 10,000. Now, now, here these pad sequences are just to yesterday I told you why we are using a padding. So just to ignore the loss, data loss, just to avoid the data loss. For that, I'll add some extra layer around the data set or our matrix, whatever matrix we are considering. I'm just adding the extra layer with all zeros so that there the size will be equal to the whatever matrix we are considering for do a matrix operation, so that I can easily do that matrix operation. So I don't want to lose any data because of that size is very less compared to the previous matrix. So here also the same thing I am doing. So pad sequences is nothing but when I am here whenever I am fixing the length of the sentences, if in that matrix, if in that the sentence will be some 30 words, so, but I have limited my matrix length is 500. So the remaining things I am making at with 0. So wherever required, the matrix I am making as a padding. So that is the meaning of this thing. So I'm doing mad pad sequences. Then pre-processing, I have downloaded the pad sequences. And here the test size and train shape I have checked first. I should be sure that both the things should be same, the shape should be same for the testing and training. Then only for the text length, if it is more or less in the matrix, we can't do any matrix operation. So for that I have to confirm the shape should be same. Then we already shared this link yesterday, RNN. So you can go to that link and you can see. So now this is the thing where we are going to build our neural network, RNN. So I have downloaded the dense. I already explained you what is dense. So it is like fully connected network. So completely connected network. And the sequential thing I am downloading because I want to make it like a layer by layer. And here embedding, embedding is nothing but it's a pre-processing encoding technique. So word embedding using the dictionary indexing, the matrix, each word will be given as the as per the dictionary indexing. So each word, each letter will be given as a no a number. So here I'm giving the 10,000 words. I have limited 10,000 words and my batch size, my feature dimension is, my axis is 32. My axis is 32 here. So I have considered my input layer with size of 10,000 and my dimension is 32. My rank is 32. And here this is my hidden layer. Only 32 neurons I have taken. And this is my output layer. So only one neuron I have taken because I just want to classify a binary classification whether the comment is a review, positive review or negative review. So one layer. And since it is a binary classification, I'm just using the activation function as sigmoid. So this is how we'll build the neural network of RNN. And now I compiled. It is a binary classification, so it is a accuracy metrics I have considered, and of course it is a binary classification, so binary cross entropy I have considered as loss function. And here you can use RMS prop or ADAM. That's not the big difference. And here validation split means test size I have considered 20%. And 80% text, 80% sentences examples I am giving as a training. So here 0.2 and this for the training, this is the epochs I have given as 10. So for the 10 epochs, if you see the accuracy, so this is the training accuracy and the validation accuracy. When you train with X features and Y is the labels. So this is the accuracy between X train and Y train. This is the thing between X test and Y test. Validation accuracy is nothing but when you are giving the X test, just check with the loss. What is the difference between the actual data and predicted data? So that is the loss. So if you compare this, the accuracy of training data is increasing up to 10 epochs. So here 99%. And the loss is continuously reduced from 0.5 to 0.02. And the validation also, validation accuracy is little bit decreased 0.78 to 0.66. And the loss is 0.46 to 1.12. So our machine has to uh, generalize more. It's not generalized more. The accuracy validation loss is increasing and accuracy is little bit decreasing, not that much. So when you plot all these things on a graph, so this is the graph. If you see this, the training accuracy is completely increasing. It is consistent towards the uh, here the towards completely increasing. And when you are taking the validation accuracy up to sometime it is generalized, it is very good. After that it is completely decreasing. So the reason for this one is overfitting. We are giving more and more data, so everything it is going to remember. So every word, whatever word we are giving, it is remembering, and that it is inputting to the next layer. So the data when you come after some time, so up to you can observe that up to here the accuracy is very good, it is testing validation is very good, but after that it is completely over, is reducing completely. And the loss also here, while training it is very good, because when you overfit your data, the training will be very nice. it will create a complex model, but the training it will learn very well. But the loss is completely increasing after some time. Up to here, it almost consistent up to this point. Then it is completely increasing. It is the problem of overfitting. Now that's why I have given here LSTM. So LSTM will think that at some point of time will it will remember that after some time it will ignore few points of few points and after some time it will ignore few things and second ignore few things and whatever it want only it will remember that points. The second so it is compiled now. This thing is I forgot to give a bracket here. I have to take it as a tuple. But by forgetting that bracket, it is taking the matrix as a string. But in machine learning, in matrix, that strings will not be accepted. So this accuracy I am testing for when I converted that RNN into LSTM. So here I am importing LSTM. So with LSTM, I am fitting my line. I am training my data with LSTM. So here LSTM I have considered. In the hidden layer, I have included the LSTM. The remaining is same thing. And now I'm compiling with this LSTM network. Now we will see the accuracy, same accuracy and loss. Here also I am taking epoch 10 and batch size is 128 and 20% as my validation data. Just the thing is I'm using LSTM. So LSTM will not remember the complete thing. It will reduce things and it will take only whatever we want that take time. So it will take time. So while completing this thing, I'll share you the quiz link. You try to attempt the quiz link on this RNN. Today's quiz is completely on RNN because GenAI, of course, now still we have to complete. So the quiz is completely on RNN and of course ENN. So we will share you the quiz link. Once that epochs will take a little bit time. So now you try to attempt the quiz link. Will share you in a second. We have shared. So please attempt this. I'll be back in 5 minutes. You complete this quiz and I'll be back in 5 minutes and our this compilation also over in 5 minutes. So welcome back. Hope you have able to attend the RNN quiz. And now we'll move to generative AI, Gen AI. So so we have up to now we have learned that AI is a complete global thing, and in that a subpart is machine learning. So it's just like assume AI is to make something decision, and to take that decision, the we have to predict something whether have to if this is good or this is bad. That is like machine learning part. In that machine learning part, you have to decide more. You should have a keen observation and you have to study well to take that prediction. So that part will do by deep learning. In that deep learning, another subset is GenAI. So GenAI actually what it will do, whatever inputs, whatever supervised learning, unsupervised learning, whatever thing we have learned in machine learning. So by taking some inputs and it is creating, it is giving, we are giving supervised, we are giving inputs and of course outputs, and we will train the machine, and the machine will able to predict a new output for if you are giving a new input. So whatever uh, things you are asking, it will do. In unsupervised learning also, you'll have some inputs and you'll get some conditions, some rules there, some patterns there, so or some relations there. Depending on these things, it will just group that inputs. There won't be any outputs. So that is supervised and unsupervised. So whatever may be the machine learning algorithm or deep learning, whatever we are asking, we are giving, and it will be trained, and then whatever you are asking, it is giving the output. But there is no that much of creativity in machine learning and deep learning. So Gen AI is first it will train with whatever inputs and outputs you are giving. So it will build a model that is same like whether it can use a supervised learning or unsupervised learning. First it will learn, but then it is able to create some new data. Its own it will able to create some new data. For example, the best example is our chat gpt. So chat gpt, if you are asking some question, so it can able to give answer related to your question. It won't skip that boundary. So that is the best example to generative AI. So it will generate the data. So that is generative AI. So how it will do that, we will see now. So generative AI refers to AI systems, but this is actually a sub part of deep learning that can generate new data or new content based on the patterns and information they have learned from existing data. So first thing, the basic thing is the main machine learning model only. In generative AI, it is not superficial thing. Its first basic property is it will learn from the data. Whatever we are providing, it will learn from the data. It will learn from the patterns. It will learn from the relations, whether it may be a supervised learning and unsupervised learning. It will learn the data. Then from the data, one more part is there. The special part is it will generate that new data. From that, whatever experiences it has, from that it can able to generate the data. And one more best example is in our Gmail. So Gmail now, all things, but Gmail, it best uses the generative AI. So if you type some text in your sentence, so the next it will give you some advices to what word you have to use in the next thing. So definitely that is nothing but a generative AI. So if you see our Google Colab also, it will create some, uh, I'll show you. So just to take a Google Colab. So everywhere when you give a new code, let's say here I'm giving a new code. So here you can see this generate. So this generate AI, you can type something. You can, if you want to give a code like, um, give me a code for adding of two numbers. Is giving the code. So it is from that experiences it has, automatically the machine learning model can able to generate something. So that is the basic outline of a generative AI. It can able to generate something. So this is the previous RNN we have left here. First we'll complete this and next we'll go to GenAI. So LSTM, using LSTM we have compiled our thing. Now you can see the plot. You can see the plot. The training is same, but in previous plot the validation is completely after some time it is completely decreasing, because of the overfitting problem in the previous graph. But here it is not completely decreasing. It is a little bit consistent compared to the previous one. So if you see um, the numbers also, you see the numbers. So first accuracy is here 0.82, and the last it is increasing a little bit by 0.85 validation accuracy. The previous case, the validation accuracy is decreased, and the loss also here it is some 0.40 and last 0.48. A little bit difference is there, not that much. So LSTM will rectify our overfitting model, overfitting problem. So this is validation accuracy and validation loss also you can see. So training automatically the loss is decreased when you trained your machine. At some point of time it trained well and the loss is reduced. A validation loss also after some time it is consistent. In the previous case it is completely high. After up to some time it is consistent. Again this is the overfitting problem. For that we have to train it better, or we have to use our regularization methods like early stopping, dropout, all some type of regularization method we have to use for this particular overfitting problem. So wherever the loss is increasing, that means the overfitting problem. So that you have to take. So now we'll back to our generative AI. Now generative AI will basically consist of two things. One is a generator, one is a discriminator. So in generative AI, our main aim is to generate the new things. So it will to generate new things, it will consist of two types of neural networks. Up to now, we have seen only one neural network. In that neural network, so many layers we have added, so many tensors we have added. But generative AI consists of two different neural networks, and these two neural networks will compete with each other each and every second. So one neural network we call it as a generator, and one neural network we call it as a discriminator. So this discriminator purpose is to learn from the data. So just like our normal machine learning model, maybe it is a supervised or unsupervised data. So it will learn from the patterns, it will learn the relations, and it will build a model. So discriminator part is building the model. And now generator part is from that whatever it is trained, using the discriminator, whatever it is trained, it will generate the new things, new data it will be generated. And it will be generated, and again it will the discriminator another function after training is it has to predict whether the generator uh, whatever the data created by generator is a real thing or a fake thing. So that is also worked by discriminator. So this is how a generative AI works. So mainly the function of generative AI is to reduce the difference between the generated content and real content, so that the generated content should be more realistic. It should be almost equal to the real data. So that is the work we'll do by the discriminator. So this what happens basically working of a generative AI. So there are two neural networks and these two always compete each other. Generator will create new things, and discriminator first it will be trained with whatever model we are taking, and then it will predict the data created by generator whether it is a real one and fake one. So and in this so many types are there. First one is autoencoders. Different types of Gen AI are there. And first one is encoders. Encoders will do here again two neural networks will be there. One is an encoder and one is a decoder. So encoder part is whatever data you are getting, encoder will compress the features, and it will pass through the neural network. It will be trained by the neural network, and after it, the last decoder will be connected, and decoder will expand the data. It will resume the compression part, and it will give you the original data, original outputs at the end. That is the basic function of an encoder. and by encoding input data into a compressed latent space and then decoding it back into the data. They generate new data by sampling from this latent space, allowing them to create variations that are similar to the training data. So first it will compress and then it will expand. Next, autoregressive models. These autoregressive models, the best example is GPT. These models actually generate data sequentially. So when you want to do a text analysis or sequential analysis, stock analysis, so it will remember, actually it will work as RNN. The most of the part is worked with using the RNN. So it will remember the thing, and the best example is like GPT. So GPT will remember, suppose if you have given one question and it answered, ChatGPT answered a question, and suppose I have asked write the code for two numbers, and it has given the code, and next question if I give explain in detail for the above code, then it will remember the above code whatever we have given, and then it will give you the sequential answer. So that is what auto-regressive model. So it will have the history of the previous layers like RNN. And the next thing is text generation. So text generation is a little bit same like auto-regressive models, but a little bit advanced model of auto-regression. So in GPT, mostly there will be, we can, most of the cases, the whatever output it is generating, that is not completely realistic. So there will be a much loss between the normal predicted data and realistic data. So that problem can be rectified by this text generation. So text generation, normally we can see that in GPT-4. So in GPT-4, whatever data, you can see the difference between GPT and GPT-4. In GPT-4, whatever data you are getting output, that is completely very close to realistic data. Human like data it will produce. So that is the function we will use in text generation. Next, image generation is, you can see some DALI website, or few websites, few tools which are using this GenAI. So if you give any data type, if you are giving any text, if you speak speech, anything, voice or anything, if you give, that will be converted into a image, a picture, that will be uh, done by an image generation. So input may be in any form, either it will be a text message or a image or a audio, anything, but output will be it will create an image. And music and audio generation, generative models can compose music, generate realistic human voices, and create sound effects. Drug discovery. In the pharmaceutical industry, generative models can propose a new molecular structures for drug candidates by learning patterns from existing compounds and their properties. Game design. Generative AI can create new levels and characteristics in most of the games. So these are the main types of generative AI, and how a generative AI works. So first thing, as I said, discriminator will learn the training process. So whether whatever may be the model, it will learn from the input and output relations. It will learn from the data. It will learn the insights of the data, and it will build the model. And during the training, the model adjusts its parameters to minimize the difference between the generated data and the real data. And next thing, after training, it is the process of sampling and generating. So once the discriminator part is over, then the generator will do the work of whatever it learned from the training examples. It will learn the patterns and it will learn the relationships. Then it will generate the new data depending on that data. So almost it tries to generate the similar data whatever it is trained before. So it tries to generate the similar data, and it always compete with the discriminator, that it always wants to make sure that this is the real data. So that is the part of generator. And the third one is evaluation and improvement. So this part will be done by again discriminator. So discriminator work will be to evaluate whatever content generated by a generator, whether it is a near to realistic one or fake. Very, the loss is very much or very less. This is nothing but evaluation. And the main challenges in generative AI. So the main first challenge is quality. So, you're having GPT-2, GPT-3, GPT-4, and so many chat GPT are there. And the main difference between all these things are quality. And sometimes for the text questions or image questions, one thing will give you the best answer, and one generative AI will give the worst answer. So there will be the quality of the data, how it is replying, how the data, the output is close to your realistic one. So that is quality and coherence. Second one is ethical concern. Ethical concern means generative AI, while generating the answers, it should be some limits to generate the confidential data. So it has to follow the ethics uh, while giving answers for any confidential data. So that is nothing but the ethical concerns. That is most important in our generative AI. So generative AI almost generates whatever question you ask, but to it has to um, accept the rules and regulations for the confidential data. And bias is already I told you, bias is nothing but while training, if we are giving a very underfitting data, when the data is not efficient to learn. So to make it generate something, it has to learn more, it has to work on more. So that's why LLMs comes into picture, large language models. So LLMs mostly we use in generative AI. So chat GPT is completely trained with only LLMs. Normal data I just will not be efficient for chat gpts. So if the data is not sufficient for the discriminator to learn, of course generator cannot able to accurately generate the data. So the bias problem is more in mm, generative AI. So first thing, we have to concentrate on the data and there should not be any bias we have to take. And resource intensive. Training large generative models require significant computational resources and energy, raising concerns about sustainability and acceptability. Next thing is future directions. First one is enhanced creativity. So of course, in most of the cases, when you are seeing in now movies also, the AI, how a generative AI will work on in different, shootings and movies, and most of the areas we can observe that generative AI taking most part to make it more clear, more visualize, more visible, or more beautiful. So the creativity is more compared to the previous normal machine learning and deep learning models. Interactivity and integration with other technologies, combining generative AI with other technologies such as augmented reality or virtual reality. Virtual reality could create immersive and interactive experiences. This thing now we can see as a students, you all are aware of that virtual labs. So that are more efficient than normal labs. Whatever we are doing in normal labs, in, with compared to our normal labs, the virtual labs are more efficient and more easy to understand a particular concept. So that will be when it is mixed with Gen AI. And basics of, already I told you the main things, two things in generative AI are, first one is generator and second one is discriminator. Generator main purpose is to create new data samples from random noise and latent vectors. It aims to produce data that is similar to the real data from the training set. So it takes random noise or disturbances or a latent vector as input and produces the data sample which is almost similar to the training set. Training the generator is trained to fool the discriminator into thinking that its generated data is real. So discriminator function is to predict the data whether it is a real or fake one. Is the discriminator. So discriminator will give you the feedback for the generator. Every time, each and every time when it is generated something, discriminator work is to give the feedback, and it will be depending on that feedback, again generator will work on the new generation and it will create the images or whatever outputs it is creating. It should be almost near to the real one. This is an example of generator A. This I took from DAL E. So here in text shape and text like text as a input, it is giving like some story, a cat and female character in a spaceship exploring a hidden galaxy with detailed backgrounds, expressive characters, including magical element, illustration made by hand. So everything I have someone is giving like in a text, and they're expecting these lines should be in a image shape. So this is done by DALI actually, DALI website, and you can go and you can create so many pictures by giving just a text or speech. Any input you can give, any form of input you can give, and you can see beautiful pictures of using generative AI there. So this is here the woman and cat. You can see that picture. So this is the applications of image generation, DALL-E and Midjourney. Midjourney is one of the beautiful website where you can even talk there. You even speak there. That will generate a beautiful picture, whatever you want. And colors also you can able to differ. Adversarial training is one of the main type of GenAI actually. It will consist of the same discriminator and generator, but in adversarial training every time the generator will try to compel discriminator that this is the whatever I have created, this is the real one. So each and every time it will compel that discriminator that see this is the real one. So discriminator will have the will it should have the power that it can able to recognize which one is the real and which one is the fake one. So and one more different thing between all the generative AIs and adversarial training is in normal generative AIs, the discriminator and first it will be trained with the discriminator, and then after the experience, the generator will give you the output. It will generate the thing. But in adversarial training, both the generator and discriminator simultaneously it will be trained. So at a time, discriminator is trained, and the same time generator will create the new generation depending on whatever it is learning. So the process is simultaneous. So that is the best thing in adversarial training. So each and every time it will compel that discriminator is because discriminator is not trained completely. So it will always try to compel that this is the real one. You try to make it sure, but discriminator able to make the difference between the real and fake. So that is what adversarial training. And loss functions. So in DL we have seen different type of loss functions. So here the loss functions are generator loss and discriminator loss and optimization. So generator loss is nothing but how well the generator is creating the pictures and difference between the realistic picture and the predicted the generated picture. So that is nothing but the generator loss, and it typically involves minimizing the probability that the discriminator correctly identifies generated data as fake. Next one is discriminator loss. Measures how well the discriminator is performing in distinguishing the real data from generated data. It involves maximizing the accuracy of correctly classifying the real versus fake data. And optimization, both networks are optimized using gradient descent methods, but here in generative AI, it's not completely gradient descent. In machine learning and deep learning, we have stochastic gradient descent and different types of gradient descents, but here it's not completely the gradient descents. So here, the training dynamics will be the balance. So successful GAN trainings requires a balance between generator and discriminator. When particularly when you are working on adversarial training, both are working at the simultaneous time. So here discriminator is trained and at the same time it is generating some new samples. So in that cases the balancing should be very important while training. Convergence, training GANs can be challenging and may not always converge to a stable station. Techniques such as Wassertrain, GANs, and various regularization methods are used to improve the training stability. Evaluation GANs can be complex metrics like inception score and inception distance. We call it as inception distance, Wassertrain distance we call that normally. We use the Wassertrain distance here for the metric evaluation. In our deep learning, we'll have the accuracy and loss or all these things we have. Now, there are some different variants we have in our GAN AI, but we have particularly two important variants we will consider while working with generative AI. So one is a conditional GAN and one is Wasserstein GAN. We'll see one by one. So conditional GAN is a standard GAN framework by conditioning both the generator and discriminator on additional information. It allows for more controlled and specific data generation based on certain inputs and conditions. And here also same generator and generator and discriminator will be there. And both the things will be received an additional information other than the LLMs. It will receive additional information. And here the loss function will be. So here the generator's loss function encourages the generator of data that fits the condition, and discriminator's loss function evaluates the correctness of the condition as well as the realism of the data. So generator loss function and discriminator loss function we will use here. And the applications of this are image to image translation, text to image generation, and data augmentation. Data augmentation is nothing but creating different different images from one image. This is one more variant we normally use in our practical Versatian GAN. This thing is actually more such as instability and mode collapse uh, while training we normally come across through instability of the data and mode collapse, where generator produces a limited variety of outputs. They use a different loss function based on velocity and distance. So this is the loss function we commonly use in generative AI. Adversarial training, in most important adversarial training, we use this type of velocity and distance as loss function. And here just we can't call this as a normal term. We can't call it as a loss in while working with the Wasserstein variants. We cannot call this as a loss. So here we call this as a critic and a loss function. Critic we normally say. So the critic estimates the Wasserstein distance between the real and generated data, just like our loss function in DL only. But in here we call that term as a critic. So critic means loss. And the loss function here, Wasserstein GAN is based on the Wasserstein distance. So this is the, just like in our machine learning algorithm, well, regression algorithm, it is it's just like, what do you call Euclidean distance. Just like that, here Wesserian distance will have. So it will measures how much work is needed to transform one distribution to another. This approach provides a more meaning gradient for learning compared to the original gap. And this is the training. So this is the penalty where we'll use for regularization. If the data is more, LLMs is more, of course we'll that will be that will happen. There will happen some overfitting problem here also. To reduce that further regularization, here we use the gradient penalty, but we cannot call that gradient penalty, so we call it as vegan GP, W gen GP. So Versettian, this is the gradient function, lipstick Lipstand constraint. So that is the penalty function we use for to reduce the critics. What about Versettian variants? Some different two types of variants. The next one is data augmentation. This is a type of a technique normally used to generate more and more data. This thing already I have discussed how a data augmentation will be useful um, in our deep learning while discussing about the regularization functions. We have discussed this. So data augmentation is a technique used to artificially increase the size and diversity of a dataset by generating new data samples from the existing ones through various transformations and modifications. We'll see one, this is the example. And synthesis AI normally uses the data augmentation technique. So here you can see from the two images, it can able to create different types of images. So when that data is not enough for the modeling, we normally do this data augmentation technique. We'll apply different types of techniques. So the different types of techniques we use in data augmentation are, so these are the techniques we normally apply in data augmentation. So first one is geometric transformations like shifting, scaling, zooming, flipping, horizontal flipping, and vertical flipping. Or we can use color adjustment. Resolution we can change, and contrast we can change. And noise addition. We'll add some random noise, or blurring and sharpening, or affine transformations like shearing, and data synthesis like generative AI, generative adversarial networks can generate new images that resembles the original data set. So if you have seen that fake fake data set, fake image, that is one example for adversarial training. And text data augmentation, that is these and all image data augmentation when you want to do something on the images. When it is when it comes to text data augmentation, it is just like text shuffling, back translation, random insertion, some random words we will insert, and synonym replacement. So all these things are the text data augmentation techniques we use to increase the data. Audio data augmentation is speech and pitch adjustment, noise addition, or time stretching, or volume adjustment. These are the techniques we normally use for audio data augmentation. And tabular data augmentation, we are going to use synthetic data generation, feature engineering, and SMOT, synthetic minority oversampling techniques. This is the one technique we are using for GenAI. And these are the libraries we commonly use it for our data augmentation process. So uh, Augmenter is the common library we use for image augmentation. Augmenter and the image data generator already we have seen. If you remember the medical image analysis, whatever we did for X-rays in CNN, so we have used this image data generator. So it will generate the images. I think you have remember this. And text augmentation normally will use the NL plug, and audio augmentation will use the LibreSoft. So these are the common libraries we use for augmentation. Augmentation pipelines are combining multiple augmentation techniques into a pipeline and apply them. This particularly this application, this technique we use in your Fusion when you are doing for images, and you have created so many images, and if you want to combine all these things to make a hybrid algorithm, so there you'll use this pipeline. And randomization is applying augmentation techniques randomly to ensure that the model does not learn any artifacts from specific transformation. So this is a basic information about GenAI. And here actually to work on GenAI, to show you the GenAI project, I need my API code, but thing is my API is not working. I didn't get any my API ID. So I just took a GP2 model to show you how a normal GPT-2 model. I have considered a simple text. So here my text, and I just show you how a generative AI model will give you the text. So this is my trained whatever I trained my discriminator, and this is the example, and my generator has to create some new lines. This is what my generator has created. Once upon a time, up to far away, I have created, I have given as an example. I trained with all the words to my discriminator. My generator created all these things depending on whatever it has learned. So it is created these many lines. Show you the program. So this is very simple generative AI program. I didn't use actually for generative AI. Is best to use any API. So you have to go to OpenCV and you have to create one API. Far from if you are working with images, you have to go for Hugging Face, and you have to get an API ID. Then you have to use that secure code, what secure ID here, and then you can generate. That will be better more. But now my API is not working, so I have took directly GPT-2 and I created a model, and I took some text and I limited the text length as 50. So my prompt, I have limited my text as 50, and this transformer here instead of using TensorFlow, I am using just PyTorch. You can use TensorFlow also. PyTorch here I am using. In the PyTorch, transformers are the main modules to generate the images or generate the text. So I have imported this transformers from the PyTorch, and I have created the model name. Model and tokenizer is nothing but when I'm working with the text, it will take the tokens of that words, and it will create a number using the dictionary index. So to create a vectorizer, to create a matrix, it will take the tokens of the each and every word. And this is my generator. So here this is my generator. So generator text, I am limiting the maximum length as 50, and this is my input and this is my output. So my input, I am taking tokenizer encoding part. I'm doing hard encoding, and here this is my token encode, and output should be generated. And here I am not limiting any maximum length. Only in input I am limiting the maximum length. This is my example. Up to far away I have given my example, and I'm asking to generate that using the words I have taken. So it is generated the same word repeatedly. The world was a land of dead. This is created a story. So this is a basic program of generative AI. Anyway, I'll share you this link. So basic program of generative AI. So I'll share you the link now. You just to try this generative AI. So if you have next any time is there, we will have a session on only generative AI. There we'll see all these things in detail, and we'll see hands-on session on generative AI. So now this is how this is what a certification program on machine learning and generative AI. So I hope you have some basic understanding of machine learning and deep learning concepts. And I think I have covered all the necessary topics, because machine learning, to learn a complete machine learning, it will take almost 6 months or 1 year. If you have to have a very good practice, then only you'll understand the concepts. But I tried to cover most important topics which you have to learn, which have to feel that basics. So whichever I thought as basics to do some projects are in real time, so that concepts you have to know. So that almost all topics I try to cover in my sessions. So if you want any if you have any doubts, or if you have any problems, tomorrow I'll give you my mail id, my college email id. Then you can contact me. If you have any project you want to do, you can contact me, we can work together. Or if you have any doubts in any topic, you can contact me, you can chat to me tomorrow in that question and answer session. So anyway, I'll give you my mail id, and this session records we will share you now, and this ppt also I'll share you now. So try to attend the certification exam. So most questions are from quiz part and whatever I taught in our class. So just listen the recordings again and go through the PPT, all the from starting day 1 to day 9, it is there in that PPT. So go through the PPT, understand something, and try to attempt the quiz, attempt the certification exam. I hope you have some valuable time in these 10 days and learn some basic concepts of machine learning. So now we will share you the PPT and recordings, and of course the feedback link. So please give the feedback, and tomorrow we will meet for the last session of question and answer sessions. And if you have any doubts or anything you want from me, any questions or any information, or any any related to projects, if you want anything, tomorrow you can discuss with me. So today I'll stop it now, and this is the end of our certification programs for the theory classes. And all the best for your exam tomorrow. And thank you. Good night. Bye bye.